And now we have Sára Juhošová, who will talk about the difficulties of theorem provers.
Good morning, everyone. I'm Sára, and I thought it would be a good idea to start my talk today by reminiscing about when I was a novice and I was learning to use an interactive theorem prover. And I'd like to do this by inviting you to help me debug this beautiful piece of Agda code that takes a pair and swaps the values in that pair. Now, back when I was a student, I hit compile and I got this beautiful, beautiful error message. So where did I begin? Okay, let's attempt to understand the message. Right, I recognize something about swap, but yeah, that's what my program is about. But then I start thinking like, what? Operators, scope checking, grammar? I'm really confused. Okay, so what is my second step? Let's ask the internet. I mean, surely there will be an answer to what this, oh, no, there are no results. Well, that's a bit of a bummer. Okay, let us try to stare at the code until we figure out what's wrong. So I'm staring, I'm a bit confused because all of my syntax highlighting is gone. I don't really understand what's going on. So I actually had to go and ask a teaching assistant for help with this. Looking back now, I think we can all agree that this is quite a lot of cognitive effort that a novice has to go through to understand the error that says there is a space missing on line 2. So I actually recently started a PhD on the usability of interactive theorem provers. And my long-term goal, or one of my long-term goals, is to identify the aspects which would, of ITPs, which would help us improve them with respect to usability. Now, I think a very good first step is to identify the obstacles that novices face when they are learning to use one. Because it is quite, I think, common knowledge that there is a very steep learning curve when you're trying to use an interactive theorem prover. And it would be quite nice to know what makes that learning curve so steep. So today I will walk you through my study that we executed on some novices. I will talk about the study setup, I will talk about the obstacles we identified, and I would also like to make some observations based on those obstacles, as well as talk about a few projects for the future. So let's begin with the setup of the study. We actually got a hold of 35 bachelor students who were doing a functional programming course at our university. And in this functional programming course, they learned the basics of functional programming in Haskell, and afterwards they had a short introduction to Agda for about 2 weeks. So they learned the interactive development, they did some Curry-Howard correspondence and some equational reasoning. And what was really nice about this setup, the fact that these were students from a course we understood, was that we had a very good idea of what the knowledge of these students was from before, during the course, what they knew, what their background was. And actually, only one student indicated that they had more knowledge about interactive theorem provers than was taught in the course. So I think we can safely assume that this is a representative set of novices. Now, after these novices took this introduction to Agda, we gave them an online survey where we asked them to list up to 5 obstacles that they encountered while they were learning to use it. We left the questions open-ended because we didn't want to restrict what obstacles they thought they faced by giving them a drop-down menu. And it's important to note that because these were free text, we turned to qualitative research methods to analyze the answers that we got. So there are 3 very important methods that we used, and I'd like to walk you through all of them because I think it's very interesting to see how a study like this can work. So I would like to begin by coding, which is essentially the process of taking your qualitative data and labeling sections of it or coding sections of it with representative names or codes. So this is an example We actually did this coding in 2 iterations. In the first iteration, we took all the quotes and we assigned codes such as syntax for Unicodes or tooling for a plugin crashing. And when we collected all of these, we made a set of them and we went through it again and reassigned everything to this new collection of codes. Now, one important thing to notice here is that, for example, this third quote that's on here is also about tooling. So it was coded as tooling. But I think they're very different, right? You can see that the first one talks about unintended behavior. So the Agda plugin is crashing. And the second one talks about something that's actually designed to be part of the toolings. It's the syntax highlighting disappears when there's a mistake in the code. So to understand these nuances a little bit better during our analysis, we added subcodes to elaborate on this, to be able to group this better and understand what this means. After all of our data was coded, we used diagramming, which you can sort of imagine like a crazy scientist moment, where you take a lot of sticky notes with your codes and put it on a whiteboard and try to understand the connections, the relationships, the groupings. It was actually really useful to visualize how these things work. And with the combination of memo writing, which is making notes of ideas about codes and their relationships as they strike the analyst. This is a very nice practice from qualitative research, where you basically take notes of what you're thinking, of what you see, and you can go back later and elaborate on it, see whether that still applies to what you think after you've analyzed some more. So I would like to summarize here a little bit that you can see from our study setup that we actually did this on a very homogeneous set of students learning to use Agda, so only one interactive theorem prover, in a very short span of time. This means that the benefit was it was a very controlled group and we understood what their knowledge was. But on the other hand, it's of course very limited because it's very contextual, it's just about one ITP. And yeah, it would be nice to be able to see more things. Nevertheless, I think we got some very nice results and I would like to present them to you right now. So we identified 5 obstacles on 3 different levels. So on the level of theory, on the level of implementation, and on the level of applicability in the real world. So I will start with the theory, because there we have 2 obstacles. The first one being unfamiliar concepts. Right? So these are students coming from a computer science program where so far they've worked with mostly object-oriented languages. They think of software as something where you serve or collect data from users. And switching to dependent types and interactive theorem provers is a very big paradigm shift for them. And you can see that they complain about things like dependent types are not intuitive, or the idea that the type checking is where most of the magic happens is very different to what they are used to. Second of all, not only is this theory different from what they're used to, it is also very complex. Right? The way you need to think about your programs is much more abstract. There's a lot of underlying theory. And you kind of have to understand a lot of it before you're able to do anything useful. So other than on the level of implementation, the first obstacle I'd like to share with you is what the students called weird design. And I think they call it weird because, of course, it is so different from what they're used to. But these are things like Unicode characters into your code, requirements about where you have to put spaces, error messages that really require a lot of understanding of what's going on under the hood, and abstractions that if you use the abstraction, fine, it's no problem, but as soon as there's an error, you have to understand everything that's going on underneath, and that's very difficult. Added to this, there is a second obstacle on the level of implementation, which is an inadequate ecosystem. So by ecosystem here, we mean, of course, all the tools, all the installation, everything. And unfortunately, what we saw in our data was that this ecosystem, while there and well-intended, is very incomplete. So we have things like, oh, I don't have any documentation about this very basic concept. It's very buggy, so your tools crash very often, they have unintended behavior. It's inconvenient, syntax highlighting disappears, and it's not very accessible to novices. And for example, if you look at the top quote here, it says, Agda docs have a lot of material about super crazy stuff, but very little on the detailed semantics of the basic language. And I think if any of you has ever tried to Google anything on Stack Overflow, or to DuckDuckGo anything on Stack Overflow about Agda, you probably got some very complicated examples that were hard to understand and for you to extract the simple things out of it that you were looking for. And finally, we identified one more obstacle on the level of applicability in the real world, and that was unfortunately perceived irrelevance. So I already said that these students have quite a big paradigm shift, and I think because they think of software as something that's intended for serving or collecting data from users, they find Agda a little bit too theoretical, and they can't really imagine writing real-world software with it. So I think here also the point is that they don't really understand what context it could be used in, when it would be useful to them in particular. So those were the obstacles, and I would like to make I think we can extract some pretty nice observations about interactive theorem provers, or Agda specifically in this case. So firstly, many obstacles that we identified are a result of the high coupling between Agda's underlying theory and its design. So we saw this on the error message, right? It's really, you see that the math came first, then came the theorem prover with all its error messages. And the users sort of have to understand what's going on in the background to be able to comprehend it. Second of all, Agda's ecosystem has very little supporting infrastructure for novices. We saw this with the internet, with asking about the error message, with asking in general for help. There's just not a lot of simple help. And lastly, Agda's design choices make it very dependent on a custom and unfortunately not so user-friendly development environment. So this, for example, means like Agda has some interactive features where you can basically talk with the compiler, and that means that you cannot edit it in a plain text file. You really need to use an Agda mode plugin to be able to leverage all the powerful features. But that plugin crashes, it does strange things, and you have a lot of maintenance around it as a user to be able to use it. So what can we actually conclude from these observations? And I think one thing that at least jumped out at me is that it really seems like we need to find a way to make Agda's infrastructure or any other ITP infrastructure more accessible and more sturdy. So really make sure the base is powerful enough to hold up all of the other cool features that are within an interactive theorem prover. And at the end of this talk, I would like to talk a little bit about what's going to happen in the future, hopefully with my project. So first of all, this was a study about novices and about, I'd say, interactive theorem provers, but of course we only examined Agda. And I think it would be very interesting to expand this view and to focus on a more varied user base, so people who do use it daily, people what they find interesting on every different interactive theorem prover. And actually, I am going to conduct a survey about this very soon. So if you're interested, you can scan this QR code or come up to me, and I would love to interview you and see how you interact with your interactive theorem prover. And for the second future point, right now I, of course, only highlight the problems. So this is kind of a comprehensive list of what I think is going wrong. But the very important next step is to find the solutions to these technical challenges and actually figure out how we can improve the usability and the onboarding process. So thank you very much for attention, and I'll be happy to take questions.
Yeah, okay.
Hi there. Great talk. Always exciting to see qualitative research at places like this. The swap example you gave, the spacing issue is a result of maybe strange or just bad syntax, not anything necessarily to do with the interactive theorem prover. Is your takeaway that these languages need to be good languages first, and then they need to be good interactive theorem provers? Or do you think there's something fundamental about ITPs that make it really hard to design the language as a language by itself?
Thanks. I think that's a really great question. And I think what we see is, I already mentioned this, that a lot of these problems are just a result of the fact that the math came first, then came the prover, and then came the users. And I think we need to figure out as a community who we want these tools to be for. And if we decide that these tools are also meant for general users, we should keep them in mind. And I think we should start designing a little bit from the user into the prover and then find the math underneath it.
Awesome, thank you.
Thank you.
Hello? Okay. Great talk, thank you. I was just sort of related to what you were just saying in response to Harry's question. I'm wondering if you think that there's sort of, we can reform these tools, or if, you know, perhaps there's room for theorem provers designed specifically for students to appreciate the underlying system.
Yeah, so I think there is definitely two ways to go, and I think they're both very valuable. The first way is if we determine that what we have now is really something we'd like to share with the world, I think it is quite worth it to invest into usability features, even just very simple ones that help the novices get through the learning curve. But I think there's also another path where we can take these interactive theorem provers and think of them as a playground with a lot of options and a lot of research material, and see whether we can take them and plug them in somewhere else, incorporate them into another ecosystem, see whether we can sort of package them nicer for a different set of users.
Okay.
Does that
Thank
answer? Yeah. Thank you.
Hi, great talk. I have two questions actually. So the first one is, you chose to use the Agda mode on VS Code, right? Which is a somewhat unconventional choice in the Agda world. I'm aware that I'm a VS Code fan, so I understand comfort, but you know, isn't Emacs the more mature version of Agda or something?
Well, I think, first of all, this is something that was not controlled by us, of course, it was controlled by the course. But I think there's a very important reason for that, which is that the point of this course was not to learn to use new tools, right? These students are used to VS Code, they were using VS Code with Haskell earlier in the course, and I think it was just a very natural progression for them. Okay. So it's a little bit the choice of, do you also take time to teach them the ecosystem you want them to use, or do you sort of let them figure it out?
The second question is about this Unicode thing. So you said that students found Unicode annoying, but I think there are two questions hiding in here. Do students find the Unicode itself annoying, or the Agda interface to Unicode annoying? Because
I think most people complain about the fact that it's just very confusing or very different from what they're used to.
So in the sense that, like, when you read a literate Agda paper, that's like there's too much Unicode notation, but the user interface is fine.
Yeah, I think it also reflects a little bit with the documentation. Okay. So if you search for a problem, you very often get super different notations, and you get, of course you can write not Unicode things, but if you want to reuse someone's library, you have to try to understand all of these things. And I myself sometimes find it really difficult to just take the effort to figure out what Unicode I need to type to be able to use a function.
So what you're in the end saying is that this is a result of overuse of Unicode on the part of people who use it, not. Okay.
I don't think it's necessarily a bad thing. I don't think using Unicode is bad, because I think it's great for the usability from the math perspective. I simply report on it as this is something that makes it even more alien to the people who are coming from more mainstream programming languages.
Okay. Thank you so much.
Thank you.
Hi, thank you for the talk. So I came to theorem proving from a different background. I was taught lean by a mathematician, and most of the people who I was speaking to at the time were mathematicians. And so I didn't think very hard about dependent types, and I'd never studied type theory, and that wasn't a problem, because we sort of came at it from the perspective of, like, I want to write mathematical propositions and prove them. And I was very lucky that I'd also written a lot of Haskell beforehand, so I had some experience with functional programming. These sort of problems and difficulties are a bit different to what you've identified, and I was wondering if you've thought much about whether, what the prerequisite skills are for learning a theorem prover. Like, we can't expect people to learn 100 things at once, and how to identify those and what we should expect from people.
I think that's a very big question, because it really depends on what the intention of the new user is, what they want to use it for, of course. For you, you started as a mathematician, and it was a very clear switch, I would say. It made sense. I think for these students specifically, from the results we got, it was, I think they didn't fully comprehend what they can do with it and why they can do it, and they were very much approaching it as a programming language, which caused many of these difficulties, I think. So I think we can discuss it a little bit later as well, but I think this is really about what you expect from the theorem prover and how you would like to use it in the future.
Thank you.
Thank you.
So I have a question about your observation of perceived irrelevance. So the way you describe the student group, I understand that from the beginning they had experience mostly in conventional programming languages. And I was thinking, if you took experienced Haskell programmers, they might perceive the relevance of Agda differently from people who are getting their first introduction to functional programming. Now you reminded me while you were answering questions that the students actually had some Haskell previously in the same course. But I wonder, is this perceived irrelevance specific to Agda, or did they not have enough functional programming experience from the course to see that functional programming in itself was potentially useful?
So I think the way I interpret this perceived irrelevance, I think it mostly comes from the fact that, like, even in Haskell, it's already a little bit difficult to do interactions with the real world, but there are, of course, ways and documentation on how to do this. And I think most of this perception comes from the fact that, well, all they really learned was to write proofs in Agda, and they never had to run their code. So what is the point of writing code that doesn't run and doesn't produce something that you can ship out into the world? And I think this is where the perceived irrelevance came from, just not really getting far enough in Agda to see what you can do with it.
So perceived irrelevance is a problem that one encounters when teaching functional programming. And so it's something that I specifically try to address to make students see that this stuff is actually useful. I wonder whether you would get different results if you experienced Haskell programmers and studied them. It would be interesting to know how much of the irrelevance is to do with the proofs and how much it's to do with just an unfamiliar style of programming.
Yeah, I think that would definitely be interesting. You also reminded me of that, I think, I lost my thought process. I will come back to you.
Sure.
Thank you very much for your question.
Thank you.
Okay, let's thank the speaker.